Problem number 4, little slope field, differential equation stuff. This was easier than some of the other ones, except a little twist in the last problem for sure. So we got dy dx equals 2x minus 1. They asked me to draw a slope field. I'll just pick a couple points. Let's say this point 0, 0. So 0 minus 0, 0, hence the slope of 0. This point right here is 1, 2, which gives me 2 minus 2 is 0. These are all getting less steep. So if you can see that, they asked me to find the second derivative in terms of x and y. So the second derivative of this is just the derivative of this, which is 2 minus dy dx, or y prime. But this is y prime, right? So 2 minus y prime, 2 minus 2x minus y. You could probably leave it like that. I just distributed the minus sign through. And then it says, determine the concavity of all the curves in the second quadrant. So the second quadrant, x is negative, y is positive. Negative, positive. So if we're going to put x is negative, that's going to turn that into a positive number. Y is positive, positive, everything's positive. So that hence, this is the second derivative is positive in that quadrant, so hence concave up. Part C says, at the point 2, 3, is there a minimum, a maximum, or neither? So I plug 2, 3 into the derivative. And I got 4 minus 3, I got 1. So since I didn't get 0, it can't be a minimum or maximum, so it's got to be neither. Nothing's going on. I thought that was kind of nice, because normally it's 0, and then we got to go from there. And just so you remember, if it was 0, I would then take that point 2, 3 and plug it into the second derivative, and that would tell me concavity, and that would tell me minimum or maximum, concave up, minimum, concave down, maximum. But I don't have to do that because it wasn't 0. And the last one says y equals mx plus b is a solution, find m and b. So we had one of these last week. Hopefully you did it, hopefully you remember it. I'm just going to take my derivative and plug in my solution into it. So dy dx is the derivative of y, which is just m, equals 2x minus y, and that's my y, so 2x minus mx plus b. So the problem is I got to find m and b for this. So what I did first was distribute that minus sign through. I got 2x minus mx minus b equals m. It's a little tricky actually at first. What do I do? But then I realized if I just bring this over here, I get 2x minus mx minus m minus b equals 0. And we have like terms, right? So there has to be, it's got to equal 0, so it means there has to be 0 x's. And then these are just constants, so there has to be 0 constants also, right? So whatever I put in there for m, it's got to give me a 0, which is 2, obviously, right? We can just look at that. So 2x minus mx. So m is 2. But then these two have to be equal 0 also, so you plug that 2 in there. You get negative b minus m equals 0, and b is negative 2. So m is 2, and b is negative 2. So a little twist on that one for sure. Everything else is pretty normal, I think.